Good morning, everybody. So, everything begins with a story. And in the beginning, really came for me on this particular trek with this particular project, began with the 5.0 Customer Advisory Board. And so it actually began at this conference a number of years ago. And the story began like this. We're in a room, and this is filled with the MySQL customers who, for the most part, are trying to direct where MySQL is going. At the time, the room has got people like in it for like Google and Facebook and Yahoo, and all of these people here telling us like, okay, this is what we'd like to see. So this is a really important meeting we have every year, where we take a lot of input in. And this particular year, we're presenting 5.0. And so we were talking about stored procedures, we were talking about triggers, we were talking about views. And we went through this entire long presentation explaining what these features were and how they were going to benefit from them. And I noticed at the end of the talk, the customers were kind of silent. And people were not really looking or paying attention to us or really all that interested. So I asked the question, how many of you all are interested in this current set of features and this current direction that we're taking the database? And about half the room raised their hands. And the half the room that raised their hands were the OEMs. And the OEMs were what? These are people who are taking MySQL, including it with their product, mainly to be, well, a cheap replacement for Oracle. They didn't really care about the direction so much. What they cared about was, could they have in a batteries included replacement of the database that they had been paying a lot of money for? And the folks who had actually been pushing our innovation, I started asking them, and they were like, well, we don't really care about these features. We don't use these features. What we need, and they started listing off things. We need you to actually integrate better. We need more replication. We need all of these pieces of the puzzle. And this is the stuff that we really need. And so from that, I started to write down notes and started talking to customers and saying, well, what would you like to see us do? And so from that, I kind of started this whole journey to find out, like, what should we be doing? What should we have been doing? And so I started figuring out a few things. One thing is we actually were needing to work on a problem. And the problem was the problems in the future. We needed to leap forward in our technology. We needed to start worrying about multi-core. We needed to start worrying about larger expanses of memory. This was something else. Further, we actually need to be easier to use. And this isn't so much of MySQL was always simple to just start up, get it running. That's always been very simple. Ease of use is one of the major reasons why MySQL came about. But ease of use also started becoming another problem. That problem is we have tens to hundreds of MySQL servers sitting out here. So what are we going to do about that? How do we make this stuff much easier to use? The other thing that came made me very, very aware was where we were going to focus. We need to actually focus on what our customer problems were. We need to focus on the web. We needed to solve problems that they were actually having at this point. Because when we started looking at the market, it became obvious. We looked at the embedded world. What database is used in the embedded world? It's SQLite. SQLite has completely been, it has went through the database world. It's on device after device. Everybody here who has one of these nice shiny iPads, your iPhones, all of that, SQLite is the database that has become ubiquitous inside the embedded world. For us to continue focusing on this, that's not exactly a good plan. The other thing that I came across was, what else did we actually need? Well, at the time, we were doing a lot of work for SAP, and SAP was interesting because they had this old product called R3, and R3 is this large ERP application. It was all built around how databases were designed, in the 90s. And so as we tried to focus MySQL on that, we lost a lot of our functionality and a lot of flexibility and a lot of our vision towards what people were interested in, what actually drove them to MySQL. Now, this in itself was an interesting technical problem for me. But a technical problem alone is really not worth solving, personally, I believe. You want to find something else that really makes something interesting. And the part of it then that really interested me was when I was talking to users, they started explaining to me all their frustrations around MySQL, and all their frustrations had to go back with, we don't see you as actually being open source anymore. We can't contribute patches. You want us to sign long forms. You want us to do all this stuff, which is unnatural. This is stuff we don't have to do in generally open source projects. We want you to actually try to function in an open source model. And so when you brought the social aspect and the technical aspect, suddenly this became a lot more interesting to me personally. So in focusing on tomorrow, so when I started working on Drizzle about 2 years ago, at the time, what was actually the questions? Well, I said, well, let's focus on the future. One thing, the world's going to be 64-bit. When I would raise, when I asked people back then, how many of you all still have 32-bit servers out in production? good chunk, about half the room would generally raise their hand. When I asked that question today, the answer is 0. Today, what did we focus on when we worked on with Drizzle? We focused on 64-bit solutions. We removed all of the 32-bit hacks, stuff to make smaller platforms work on that. Can we still run on it? Sure. Does it really matter? No, because what is your laptops? What are your servers today? They're all 64-bit. And all that code that existed in the database to try to make stuff work on 32-bit environments was just more code for developers to have to learn. It was just more baggage that we were carrying on. What else did we look at? We started looking at what is disk going to look like. This is one of the things we're looking at very closely today. SSD. In 2 years, SSD is going to be the most common disk. It's already in my laptop. It's in a number of your all's laptops. This is going to be throughout the server environment. Someone comes to me today and they say, hey, we're going to go spend a bunch of money on consulting. And, this company has said, they come in, it's going to be about $3 grand, 10 grand. And I said, just out of curiosity, have you decided to spend, say, $500 and buy some SSDs for your couple of servers, $1,000? What was your performance gain there? It's excellent. That's going to be the common case going forward now everywhere. And so we focus a lot on that. So when we started looking at the problem of how are we going to create a new MySQL, let's actually focus our new MySQL, our Drizzle, on actually this problem. Let's look at SSDs. No more locks. The world is multi-core. When we first started talking about this stuff, we had people who had 4-core boxes. And MySQL performed kind of poorly in that. MySQL performs pretty poorly when you go beyond 4-core. And we started asking ourselves, what do we need to do? We need to actually remove locks. We don't need to actually try to make locking a little bit better. We don't need to try to partition off our locking systems. What we need to do is go in and solve the problem. Move to lockless designs. Get rid of locks. Because we know that while today you can kind of get around locks a little bit because maybe you have an 8-core system, maybe you have a 16-core system, maybe you have 24-core systems on the way. We know that right now, focusing on where we need to be focusing on where the future is. And the future has many, many cores. And many, many core systems mean what? No new locks. Other things, we need to focus on how modern applications were built. People don't use stored procedures in the way that they've used them in the 90s. Let's see how people actually execute SQL today, and let's function based on that. And the other thing we looked at was, well, when MySQL was created from Unireg a decade ago, C++ was not exactly the most advanced language at the time. There was a lot of things that we would question, and things like, well, you don't want to do that in C++ because it's not fully baked. And the thing that we have found in the last 2 years of working on Drizzle is what? C++ is fully baked. And also, what is college students learning? If they learn anything, what? They're learning object-oriented programming. So we said, okay, let's go back. We're going to actually go from C+ to be actually using C++. We're going to go back and examine the STL. We're going to examine Boost. We're going to examine these libraries. And when we find that they're good, we're going to use them. Because here's the thing. All of these libraries are a part of a larger open source community. And there are more people who examine these libraries. One of the problems of eliminating bugs is really how do we actually get more eyeballs viewing code? How do we get and leverage larger audiences? So what we decided to go back in when we started working on Drizzle is how do we go take what other people are using, reuse it ourselves, find the best pieces out there, and then what? Make use of that, encourage other people to actually use that stuff. So Drizzle today is C++. It uses STL, and even recently we started using Boost. The other thing was we wanted to make things further easier to use. And in this regards, both from the standpoint of how deployment works to actually how does somebody go about using the database. We have one blob type. There is no tiny blob, medium blob, papa blob, mama blob, whatever else that exists. There is just a single blob. We know the fact that there is what? Blob in MySQL can use up what? Between 1 to 4 bytes in memory? A blob is many, many megs. Why are we wasting all this code time trying to figure out 1 to 4 bytes on the front end of a header when the blob is what? Megabytes in size. The additional memory, it is irrelevant to these problems. All it does is add to code bloat. What does it do? It makes developers sit around and think, well, should we have optimized by using a tiny blob over a medium blob? When in the truth, what's happening inside of InnoDB? It actually has one blob type. No 3-byte integers. This is a famous one. People goes off, use medium int. They're like, well, we saved everything by using a 3-byte integer. And then suddenly their application space runs out of numbers. And what? The comparison, moving this stuff back and forth between this. I remember when I talked to the Intel people a while ago, and they were like, that 3-byte integer, we actually never built a processor that can really work with those things, right? That's something we never actually did. Like, yeah, we're quite aware of that. No 3-byte integers. Take the types that are actually used, make those the types that people are actually using. Make things simpler to use. Also, let's just solve really stupid problems. The web is UTF-8. I go and I talk to somebody, and they're like, yes, I built this great web application. We put up this form, and all these people from India and China have been entering the data into it. And I'm like, yeah, do you read Chinese or Hindi or anything? And they're like, no. Have you ever tried to display the data? No. Do you know that your table's probably sorting on Swedish? And they're like, really? I'm like, yeah. Yeah, actually, that data that's been inserted is probably actually all corrupted, or maybe working. Let's remove this stuff. The web is UTF-8 at this point. Let's just insert data into the database UTF-8. If you need something else, we have binary data store. But the truth is, if you're inserting data from the web nowadays, what are you doing? You're inserting UTF-8 data. Let's make this stuff the default. Let's not actually screw developers who are sitting there who may not know, by the way, this one particular detail. No gotchas. So this is probably one of my earliest annoyances with MySQL, and I've worked with MySQL since about 1998. No bad record inserts. In Drizzle, if you have an enum that is yes and no, and you insert the word pig, we don't insert a null or some kind of empty space or whatever else. We throw an error. If you insert some kind of, thank you. I don't know how many times people have gone like, I've given this talk in audiences and they were like, hold it. You mean it would actually insert the word a null, and they'll go back to their applications. People don't even realize this. They're inserting data, and the record in their data is becoming corrupted. We've gotten rid of all that stuff. We've gotten rid of hidden truncations. There is none of this like, well, we copied the data onto a system which was file system case sensitive, and then we moved our data over for not, and then suddenly none of this stuff actually happens. We have real data dictionaries nowadays. We actually store stuff properly. There is no file system case sensitivities. There is no modes. There is no, hey, we actually want to enable February 31st as a date. You don't need a mode that enables February 31st as a date. It's a bug. You don't actually need to do things like, well, do we need to do ANSI compatibility, or do we need this compatibility? All of this stuff just complicates your application. And it complicates your setups, because what happens? You go to deploy your servers, one configuration file is wrong, and the next thing you know, all of your data is incorrect. No modes. Other thing we did, we looked at Drizzle and we said, how do we make Drizzle infrastructure aware? When we talk about databases, for some reason, people have this concept that they're an island in the middle of their data center. Databases shouldn't be an island in the middle of your data center. Databases are another cog in your infrastructure. They are another piece of the infrastructure. Inside of Drizzle, what have we done? We've moved authentication and authorization out. We've tried to take things and actually make it so that when you install Drizzle, Drizzle is a part of your environment. Not an island unto itself, but an actual part of the infrastructure that it fits in. And this is when we get into what is ease of use. We look at Drizzle as a part of the infrastructure. The last piece on this is organic open source. I am a big believer in open source, and I am also a very big believer in doing it organically. And what do I mean by organically? That means that in our worlds, everything is public. We have complete transparency. There is no version of Drizzle sitting out there that has 3 or 4 features that someday we might provide back to the community under some license or in some of the cases. Drizzle is entirely open source. Release early, release often. Every 2 weeks, we release a new version of Drizzle. That's it. Every 2 weeks, we drop a new release of Drizzle. We do this by what? We keep our trees green. We keep everything working. We actually make sure that testing is ongoing. Every 2 weeks, we drop a release of Drizzle. There is no last-minute dashes. There's no nothing. It works. Every 2 weeks, we take Drizzle and we release it. How do we do all of this? We use things like Launchpad. We put all of our source code up publicly. There is no secret source code to Drizzle that's going to have the extra special feature of whatever, anything. It's all sitting up on Launchpad. If you want to see what people are working on, you can go to Launchpad. You can look and see some 200 open trees right now where people are working on different projects. Everything is open source. And here's the last piece that's pretty important to me. There is no Drizzle Incorporated. We're not doing this the same way this time. What are we trying to do? We are trying to do the same thing. Part of it made successful for Linux. What do? We have an open code base. We allow people to fork it. We encourage people to build products around it. We encourage people to build databases around it. What do we function on? We function on the concept that there will actually be rising water. More people use the code base, many people will rise, many people will reinvest in what we are actually doing. This is something that's been very, very important because we do not want to create a company, once again, where there isn't any kind of a stranglehold over any kind of innovation. We want to encourage innovation. If 5 years from now somebody comes along and forks Drizzle, and Drizzle becomes this entirely new entity based on what their vision and what their views are, that means success for us. The world now, it's funny, open source projects are really scared. We see things like GitHub existing and like Launchpad. Now, recently I heard developers, well, we don't know if source code's coming back anymore. And really, that's not the fearful thing. Fearful thing would be is if no innovation was occurring. This is important to me. There is no Drizzle Incorporated. There's not going to be. There are many of us who are actually going to provide services around it, and there's many of companies that are working with us. But there is going to be no central company. Everything is based on community. So when we look at all of this, what is all this really adding up to? This gets into the world of where we start talking about what is a modern infrastructure. Modern infrastructures have multiple clients. We have routing proxies. We need to be able to do cache things inside of routing proxies. We need to do things like be able to support SQL and REST. The term NoSQL is not one of my personal favorites. Here's a better term, also SQL. We need multiple interfaces. We need to be able to speak to databases, not only in SQL, but in other languages and other environments as well. So in our world, this is that environment. We look at this. We need to be able to handle multiple parsers, multiple optimizers, storage routing, a single node database. It's useful. There's so many people who actually need this. A lot of data sets, around 20 gigs to a terabyte. That all fits on a single machine. That's awesome. But in large infrastructure, what do they need? They have big, giant, SANs. We have NAS devices. We have all this storage arrays sitting out there. So we need to actually build a database such they can actually handle a world where storage is just another part of the stack inside the database. So in the Drizzle world, you see the green lines? That's Drizzle. We talk about this, and it was something someone pointed out to me when they were initially looking at the slide. What exactly is Drizzle? Drizzle is not, necessarily one particular dialect, one particular protocol, not one particular piece of the optimizer. What is Drizzle? Drizzle is actually the glue. The pieces that tie all of these components together, that is what Drizzle is. Drizzle is that processor that actually handles that. Our kernel basically represents how do you plug in pieces. And our plug-in interfaces today, these are a few of them. Today, we can plug in our replication system. Our replication system, entirely pluggable. You want to pop a new one in? That's fine. Storage engines. We've continued with the ability to actually plug in multiple storage engines. Because when I talk about data routing, storage in the infrastructure in the enterprise, let's face it, that's going to become a whole lot more interesting in the next few coming years. We can do logging. Logging was beautiful. I put up the logging API, and about 30 minutes later, I get a request from a push from somebody who had done what? Syslog. They're like, you know what? Error logging, going to a flat file, going into a table, not useful for us. What do? We use syslog. It was not useful for them to actually put stuff in this out-of-the-way place that they're going to have to then scavenge. I talk to so many monitoring companies, and what are they doing? They're sitting there trying to dig data out of their data, out of these databases and go off these machines. Screw that. That's not modern. Let's actually put APIs up, connect to those APIs, send data there. Authentication, authorization, table functions we do nowadays, regular functions we do. By using regular functions, we can actually do things like implement pieces into, say, Gearman. So we can actually do MapReduce pieces directly out of the database, the kind of stuff that we see Greenplum and Astrodata and other people actually doing. Protocol. We need to be able to support multiple protocols. Query rewriting. Come on, web servers have had this ability since the very beginning to rewrite queries. We've now been able to do this for about the last 5 or 6 months. This stuff, we should have done this a long time ago. We can actually do things now, pluggable interfaces around XA. Replication has been one of the big pieces that people have asked. So what do we need to be able to do in replication? So in our environment, we have created a replication system. What have we focused on? We have focused on geographical replication. We have focused on how to get your data safely, completely to another system so you can do backups for whatever you want to do. So how do we do this? A while ago, when we first started up the project, Google released Google Proto-Buffers, and it's a serialization method. And what's really, really, really awesome about this is that it works with Perl, Python, it works with PHP, it works with C++, it works with Java. So let's create a message format. There should be no MySQL bin log tool where you go and you try to read some files off a disk. That's not the answer. The answer is you put it in a standard API that many people are actually working on so that anybody can take our replication stream. The first time we had a replication stream going, I peeled the file off in Python and in about 30 minutes wrote a little replicator. It's so funny to be able to say, well, we spend years working on replication, and the most basic form of replicator, Python script, 30 minutes. Really not that hard. We actually replicate the row transformations themselves. So there is no, hey, well, we had a time zone on this box, but the time zone might have been off on this box. It removes that whole question you used to have to ask of, well, is your replication deterministic or not? The person who's writing the application should not have to be concerned of, did we write a deterministic application? Is it going to reproduce the same results each time? That is a flaw in logic. Worked really nicely in the beginning because it was really nice and fast. But what happens? You start to scale out, you find data corruption issues, just doesn't work. Other things we do, we actually immediately, by having these APIs, we've had people be able to integrate today with RabbitMQ, Cassandra, Memcached, Gearman. These systems, we don't only need to replicate into databases. There's all kinds of systems. When we think about SQL-based databases, we don't need to replicate into them. There's even a tree to go up to get into Postgres. All of this stuff, it should be completely open. In the environment of the enterprise, you have an infrastructure. You have a bus already. Let's actually send data out onto that. Other things we've done, we implemented libdrizzle, supports Drizzle, supports MySQL, supports SQLite. It's asynchronous. What else is it? It's BSD licensed. I never want to have another conversation again on the issue of, is the protocol GPL? How does exactly my application link with this stuff? I absolutely hate those conversations. I am not interested in them. Let's just make the whole thing BSD and in the conversation. You can link to Drizzle. That's awesome. Move on. Authentication, authorization. It is no cost to do in our environment. If you don't install a plugin for this, there is no cost. There is no 3 or 4 lock systems you go through. If you're somebody who puts your logic up in your application, what happens in that environment? You don't need it necessarily in your database. And if you don't need it in your database, it shouldn't cost you anything. PEM, LDAP, we have plugins nowadays to work into modern enterprise authentication systems. Table functions. The thing about the information schema is what? It materializes all of its data. In our environment, we implemented table functions. We've been able to really quickly extend that. We now have new data dictionaries that are around table cache, around table definition cache. We can do things like show temporary tables. We have an all-new SQL-compliant information schema. Our information schema is just what is in the SQL standard. It is no more than that. It is in what is in the SQL standard. We have not modified it. We're sticking to the standard. That is all that will be inside our information schema. Because why implement it to do anything else? In the storage engine world, for nearly 2 years now, we have by default been a transactional database. It's one of the earliest changes I made. Why? Because for the most part, people want to know that when their database goes down and their database comes back up, that the data is going to be there, that there's not going to be any corruption in that data. So we switched to being an all-transactional database nearly 2 years ago, and we fixed all of our tests. When you type make test on Drizzle, you're seeing that run against a transactional engine. That took a lot of work. It takes a lot of work to actually switch the core over to actually think about and be transactional by default. There's no more table-level locking inside of our design whatsoever. We can't support even engines that do table-level locking anymore. Why? There's no use for a table-level locking engine anymore. Our database, we don't go anywhere near that. And our data dictionary is federated. What does that mean? If you have multiple storage engines internally, what that means is that we ask those storage engines for what exists in that storage engine. We don't have anything like an FRM file on disk. No corruption can occur in these cases. Why? You do not want the storage engine and for some file on disk to be out of sync with each other. That's an actual disaster. You don't want that sort of do. And now I'm going to show you a demonstration. There's a company called Aker that we've been working with for a while. And what they've done is they've actually ported their storage engine to Drizzle. Patrick here is actually one of our Google Summer of Code students that came around last year, worked on Drizzle, and then got a job right after it. It's been kind of nice to see that the Google Summer of Code students can actually find work working on our stuff. And so if it's coming up right now, so let's pull up Drizzle and see what happens. So here we go, Drizzle. And you can see show schemas. And let's go and actually use. So here's their storage engine. You can see here, show create table, customer. Now, their storage engine is a couple of important things to know. One thing, it's a shared nothing storage engine. So they have multiple backends. Can you pull up a second window with Drizzle? You can see where he's actually selected data. And notice, let's connect to Drizzle here, but let's connect to it on another server. Do show tables, show schemas. Notice what we're seeing. We're seeing Drizzle being able to work as a federated database. That means the fact that the storage engine who, sitting here, is completely capable of talking to multiple front ends, is all being able to actually provide data to Drizzle at this point. It is the ownership of the data. So this is kind of neat. A lot of the stuff coming forward that we're going to be doing, a lot involves shared nothing systems. As you can see, select from that. And what's kind of cool about their particular system, pull up another prompt, show them off the MySQL one. Their environment, they can actually still even connect to MySQL. So you can actually still have a MySQL front-end processor working on it. So what? If you need a MySQL application, it works. On the same token, Drizzle, which can actually expose all this nice federated ability to talk to multiple front ends, is also capable at the same time. So it's kind of neat to see exactly how some of these environments go. And what's also really sharp about their environment, let's do one more step. Let's switch to the final WoW one. Notice, Memcached. So there we're actually able to talk to and speak the Memcached protocol. So this whole needing no SQL, SQL, how about also SQL? There's no reason not to provide it. And notice this is something that I find pretty fabulous about their engine. Notice that it brought back this JSON object that exists that had customer ID. They're actually doing internal joins already. They actually understand the relevance to data inside of their engine. So it's not like you have to do, they're basically pre-doing their joins at this point. Relational data should have been relational much more deeper than what we did necessarily. So while we can provide it in table operations, notice we can provide it also in a non-SQL environment thanks to their engine. So this is a pretty cool example of people making use today of Drizzle technology. Thanks. So what are some of the highlights here of what actually we're doing since we started? One thing to know, we've had 80-plus code contributors. I went back to look through the numbers. So there's been 80-plus people today that have come in, provided patches to Drizzle, and sometimes it was a bug fix that they needed for their own work. Sometimes they've stuck around for months at a time. Oftentimes, we still see them today. So we've had 80-plus people actually do code contributions within 2 years. There has been never a time in our history before in the MySQL ecosystem where we've brought in 80 contributors to the project within 2 years. That's pretty awesome. The next one's fun. The next one is we have 4 companies today that actually have core developers to Drizzle. We started off last year. So our goal last year in 2009 was to have one code contributor that did not, one of our core developers that would not actually work for Sun. We had a goal for this, and we achieved it by the end of the year. We actually found one other additional core developer last year that did not work for Sun. And we were really hoping to achieve, and this year, our goal was we'd like to have 3. We'd like to have 3 core developers that did not work at Sun Microsystems. Good news, we completely achieved that. Because of the 4 companies with core developers, obviously none of them are at Sun Microsystems or at Oracle at this point either. So we had a great success on that this year, thanks to Oracle. Other things we've got. We have today 41 active translations in Drizzle. That's the largest number of translations we've been able to find for any of the different forks or distributions. 41 active. And the thing is that nearly 30-plus of those active translations started within the first 4 months of us actually announcing Drizzle. So that's been great. We've actually gotten ourselves to actively translate ourselves into languages that we never thought would be done. There's like 3 different forms of the sub-Indian continent languages going on inside of our translations right now. That is awesome. So what does all this also mean? One of our big things was we wanted to actually reduce down functionality. We wanted to take certain pieces of functionality, toss it out. We knew that certain features didn't necessarily work very well or really weren't designed for a way that would work in the future. So today, what is Drizzle? Drizzle today, in our kernel, we're about 109,000 lines of code. And what's that? Why is that important? Because 109,000 lines of code is code that people can wrap their heads around. When we have new developers come into the project, if they have to look at 200,000, 300,000, a million-plus lines of code we saw originally in the 6.0 code base, developers just can't follow that. You just can't do it. And our code base continues to actually get smaller. And why is it getting smaller? Not because we're still removing features. We've been adding features for quite some time now. It's because we move that stuff out to plugins. Because if I'm a developer that's working on particularly one part of the optimizer or one part of the runtime, I don't necessarily need to be stepping all over code that involves authentication or authorization. That stuff is all off in plugins. And people who work on those pieces, who learn those APIs, they don't necessarily need to learn anything about the optimizer. Separation of state inside the code. Keep things moving out to different plugins. This was really actually important to us when we started working on this. Another really big issue. At the time when we first started Fork, we typed make. We would see page after page after page of warnings and everything that we probably knew were errors in the code base. And we spent nearly a half a year in the beginning doing what? We cleaned up all warnings. We cleaned up all warnings in the code base. We can't pass strict alias today. Thanks to Boost, in about 2 months, we'll pass that one. After that point, we pass even pedantic. We actually went on and did the Sun Studio compiler. We have worked very hard on getting ICC compiler, Intel's compiler finished, which we have not done yet. But there are no warnings in Drizzle. All warnings, when we compile, immediately become errors, and they don't actually end up in the tree. This is really, really important, because those warnings, somebody can sit and tell you, well, that warning, the compiler isn't right, or that warning, you know, it doesn't really matter, and I'm here to tell you that is entirely bullshit. It turns out that all those warnings do matter. The compiler is normally actually right. Believe it or not, that compiler, which has been compiling millions and billions of lines of code, was right. You, on the other end, the developer, who think you read about something, who thinks something differently, you are not right. The compiler is actually right. We treat all that stuff as warnings, and all that stuff is gone. Other thing that we've done. Today, every time we push code into what we call our build branch, because the build branch is still even 2 steps away from our trunk. Everything is tested against DB22, we test against Sysbench, we test against SQL Bench, we test against Slap, we test against CrashMe. Heck, I think we've got even another one there I forget about sometimes. We run SQL Bench across multiple engines. We run Sysbench, read-only, rewrite. We run it on different architectures. Because what are we concerned about? We're concerned about regression. We're concerned about testing. We do a lot to make sure that Drizzle is constantly tested, and we constantly crank up the number of test cases we can find. We constantly look for more systems we can actually test against. Testing is extremely important to us. We don't allow code into the tree. And here's the thing. Any Drizzle developer that signs up, we give them access to a thing called param build. So it's not like you have to wait till your code finally reaches us before you can actually test it. We hand out param build accounts, and then you can run your code against all these tests, against 30-plus forms of platforms, all before it ever touches us. Which, by the way, I like, because I'm the one who has to actually review this stuff. Other important things, on kind of a nitpicking one, we have only 440 go-tos left. Speaking as somebody who has to read code all day, compared to the plus 2,000 that existed originally in the kernel, this warms my heart. Because that go-to logic, believe it or not, it doesn't turn out to be any faster. And not only doesn't turn out to be faster, it just turns out to be buggier. So thank God. That's a little gear-headed, but for all of you who don't programs, just think go-to bad. Make fun of people. Other things to know. We've had actually a lot of luck actually with people helping sponsor us. You know, from pretty much from the beginning, we had Rackspace, who have been providing us servers, and nowadays provide employment to a number of the core developers. Intel, immediately when we actually started doing work, stepped in to help us out, and Intel has been a wonderful partner. Akiban, which I showed off the storage engine earlier, they will help work on our things like on our query rewrites, help work on our optimizer. That's been great to do. Blue Gecko has donated Rackspace for us for some hardware that's a little more on the exotic side, stuff that Rackspace would not necessarily have. Google has actually been also very nice to us. They've helped actually us run our, given us space for do meetings. This year, we were one of 2 databases that were selected for the Google Summer of Code project, us and Postgres. We had more than 48 applicants today to actually work on Drizzle projects. And if I look back at the students we had last year, this is going to be totally successful. I never have worked before. This last year with Google Summer of Code entirely was a changed experience for me. Because in previous years, we'd have students work on stuff, but the odds of that code ever actually getting back into trunk was pretty much less than 0. It occasionally happened, every so often. You kind of feel like you're wasting people's time. In our world, though, every single one of our Google Summer of Code students got code back into our trunk. And every student we accept this year, I expect to see the same thing. And of course, Sun also helped us out in the beginning. So, the other question that comes up yet, are we there yet? Should I be using Drizzle today? Here's a completely honest answer. The default engine has been transactional for over a year and passing all tests now for over a year. So when you insert data into Drizzle today, I feel pretty comfortable you're going to get the data back out. How about upgrades? Upgrades are still going to require reloading of the database. We're not entirely happy still with some of the data formats that we see. We know that we can do things. I mean, I read on the Planet MySQL the other day some of the stuff with decimal, and I go back to my notes saying, yes, decimal must be fixed. And that stuff. And to fix decimal, we're going to end up changing the formats again. You know, sometimes we run Drizzle for months at a time, and nothing changes, and you'd be completely fine not actually having to dump your database and reload. Sometimes we'll change it. You know, we've been known to change it 3 releases in a row. This is something. So if people who are using Drizzle today, you still may be dumping your data out. And that, for a lot of environments, you may not necessarily want to do that. Our replication is still under testing. At this point, would I completely trust our replication to replicate data? No. You found Jay Pipes, who's sitting around the audience, who has worked a lot on that code. Jay will tell you exactly the same thing. We're still doing a lot of testing. Good news is we have a lot of people who are interested in testing it, and so we have some good testing going on. But today, we still need to actually do far more testing on replication. We're going to be happier with replication in the near future, but we're still not there yet. So where actually are we going in all this stuff? Well, a couple of things can be answered to that. One, Rackspace. Rackspace is coming out with a beta for their Cloud Sites web platform sometime this summer or late fall. So what you'll be able to do is you'll be able to go to Rackspace, fire up an instance of Drizzle, and have your own Drizzle instance to do with. So they're at least feel pretty comfortable with enough to be saying that. And you know, with a great quote I got from their CTO when I had asked him about this slide, he said, you know, they're committed to Drizzle to succeed for not only our needs, but for the community needs. They actually really believe in open source. They really believe that if you know they put their efforts into this and we work on this stuff together, and that you know the Drizzle can succeed, that they are not only going to succeed and not only going to fare well, but at the same time everybody else is going to. And I really like that actually as an attitude. And you know, part of what they get back to us this is that you know we didn't approach them there's no vendor that approached them. There was no sales guy that came in and said, hey, we want you to do this, we want you to pay for this, we want you to sponsor this, and can you do this? What they did is they came in, started providing resources, started helping us out, and realized that we worked as a true team, something that was a little uncommon to them when they've had to deal with things in the past around this. And this was something that was very important, that they came to us and they were like, okay, you guys are actually an open source project. We can invest in you guys, and we can actually be a member of a team. And you guys don't have a sales guy, you don't have a marketing guy that's going to come in and try to convince us of something. So this was actually pretty fun. Other things. So what exactly is we're doing right now going forward? First thing, better usage, tracking, handling resources. Obviously, this is a Rackspace need. If you have a database deployed today, what do you want to know? You want to know more about what is actually going on inside of the database. You want to be able to say, this user should have this much resources and no more than that. It's been funny. One of the most common requested features when I talk to people about what would you like to see is something that might not actually everyone agree with in the room. One of the features they've asked for is, you know, when we go and do a query, if that query may need to create, for instance, an internal table, and that internal table is a memory table. If that internal memory table fails, don't go start writing it to disk. If you start writing that to disk, all you're doing is filling up my disk. And what that's probably done is what? We didn't catch that in QA. Now it's out on production, and that is not something we want. We would actually like to see you do things in the database so that we can actually control this type of usage, because nobody really wants a runaway query. It's kind of the interesting thing. A couple of people have asked us, hey, can you remove the Cartesian join? Because nobody ever types a Cartesian join on purpose. Nobody ever sits there and says, I really want from A, comma, B, and hits the return key. What happens there? That was a mistake. That's a runaway query that somebody's going to have to kill probably if you've got a lot of data. Believe it or not, some functionality is not functionality that you necessarily want. More authentication handlers. We still see people coming in asking for more types of authentication handles and actually be able to do additional things. So where we have LDAP, we have PAM, we have HTTP, there's more authentication handlers that are going to be coming in and more ways of actually handling authorizations. Hardened replication. We're actually going to harden up the replication in the next few months. A lot of the work we're doing right now involves of, did this data replicate correctly? Going back and looking at things like, okay, create select. How's that actually supposed to be able to function internally? What happens in replication if, for instance, a DDL statement tries to do something it shouldn't do? Let's catch all this stuff. Let's make sure it all happens correctly. Let's make sure that it replicates in a means such that we can take that message, we can take that DDL operation, copy that information over to another machine, and more importantly, that you could take DDL, pull it out of the message format, and then put it in a message format for a different database, for something like Cassandra and so forth. So this is something else. Other thing, shared nothing storage nodes. What you saw with Akabon today is just the first. We have a number of other shared storage systems coming about. And I suspect at least one or two that we don't know about yet, just because somebody out there is writing one. And that's something we spend a lot of energy on as well, is making sure that the Drizzle processor sitting there, our SQL processor, our core of our engine, really can work with shared nothing environments. Because the future of what we're doing in the enterprise involves shared nothing solutions. And so we know that, and we are enabling the database from day one. We're not keeping things in single files. We're focusing the architecture on to allow all engines to be engines. You know, some of the free stuff we get, when we started working on freeing up the back end and fixing some stuff around, say, InnoDB, one of the things we obviously realized that, you know, we're a step away at this point for having full transactional DDL. Because what? Hecky actually had that stuff built in InnoDB. It's just not visible from the upper layer. We've spent enough time right now in our system, we're going to be able to make that stuff visible. We're going to be able to very quickly actually provide you full online DDL operations. We're going to be able to hand that type of capability to engines that can actually support that kind of stuff. So we've spent a lot of energy on that. The other thing is we've been looking at is server-side scripting. Let's not only think about stored procedures. Let's actually go back and think about this differently, because you probably what? How many people here want to learn a new language or want to learn a fairly crippled language? You don't want to learn it. You want to learn, you already know Python, you know PHP, you know Ruby. Why don't we just give you stored procedures written in the languages you already know how to do? And let's allow you to run those stored procedures in the database or near the database, because you may find after a while that you may not want that running in the database. You may want it running near the database. This is something when I look and say, for instance, what Hadoop is learning. This is some of the lessons we can learn there. And the most important piece I'll add to this is your work. What our roadmap is today is what? It's what perhaps somebody has an itch they want to actually scratch. It is what, you know, Rackspace wants or needs. It is what any number of Google Summer of Code students want to work on. It's what I want to work on. But it's also your work. Any of you are in there today who are actual developers and, you know, are thinking, well, I would like this feature in the database. I would like to see this extended. You know, we had a user show up, a Drizzle user show up about a month ago. His name is Joe. What did Joe want? Joe actually just wanted to get better user stats. What has Joe been working on for the last months? We've started ripping out of the old com stats. We put in a whole new set of user statistics information so you can get much more interesting information on users. Why? Because that is what he needs and what his company needs. Was that a part of any kind of grand, you know, roadmap that we had either created at Sun or we created with other companies? No, that's what that developer needed. And he's what he brought to the table. So when we look at what our roadmap is right now, our roadmap is based on what your work is. And here's the thing, Drizzle, we would do major milestones every 3 to 4 months. There's no waiting for a year or 2 years to get your work in. If you can build code, it can actually pass tests, and it can function well, it goes in our trees, it gets out to users' hands quickly. Because you can't wait on releases anymore. You know, Linux got this right with the kernel a while ago. The whole release model of doing software is dead for anybody who actually cares about the edge and is actually doing new application design and moving forward. You know, sure, we can spin off a version, we can keep that particularly stable, but you know, a lot of times when I talk about companies who are actually innovators, they care about what they can get their hands on quickly and what they can do with what is here today. They don't need to hear about any kind of roadmap that's going to tell you what's going to be done in a year or 2 years. That is not internet time. It does not work anymore. So finally, if you're interested in some of this stuff, on Friday, we're doing a Drizzle Developer Day here at the conference. So if you're interested in learning more about how to use Drizzle, if you're interested in learning how to develop software around Drizzle, if you just like to hack on C++ and you're looking to actually bone up your skills a little bit, come the day. We have a 2 rooms set aside, room 2009, 2010 here at the, 209, 210, here at the conference, and you can come and see what everyone else is working on and perhaps provide your own ideas. Drizzle.org, we've had our domain up for a while now. Planet.drizzle.org, so if you're interested in yet more information about Drizzle, you can always look at Planet Drizzle. Freenode Planet Drizzle. There's usually about 71 people on the channel at any given time, and there's enough Drizzle devs around the planet. There's pretty much always a core dev in there. So if you'd actually like to find somebody, ask a question, there's always people available there. And sometime in the next part of the summer, I even get to announce 2 different companies that are going to do formal support for Drizzle. And that's going to come along probably by the time we hit around OSCON. So if you actually want to buy support, you're going to be able to do it too. So that is all, and I thank you for the time.